This is a multiple-choice question about scikit-learn's powertransform function, a tool used in data preprocessing to make data more suitable for machine learning models. The question tests understanding of how powertransform works and its capabilities. Let's explore what the question is asking. This sets the stage. The question focuses on the powertransform function within scikit-learn, a popular Python library for machine learning. We need to determine which statements about this function's behavior and use are correct. It's important to understand what the function does. This statement addresses the Johansson transformation, a key part of the powertransform function. The Johansson method is powerful because it can handle data that includes zeros and negative numbers, something the Box-Cox transformation cannot do. So, this statement is about how powertransform adapts to different types of data. This statement describes the main goal of the powertransform function. Data that is normally distributed, or Gaussian, is usually easier to work with for machine learning. Stabilizing the variance, reducing the spread of the data, is a way to improve the overall quality of data for modeling. Think of it as making the data more consistent and predictable. This statement focuses on the Box-Cox transformation, another method used by powertransform. The Box-Cox transformation only works correctly if all values in the data are positive. This is a key constraint for using the Box-Cox method within powertransform. This statement is a bit of a trick. The powertransform function can use either the Box-Cox or the Johansson transformation. It doesn't always use just Box-Cox. The user specifies which method to use, allowing flexibility depending on the data characteristics. Hey Vamsi, this line introduces the topic. We're exploring scikit-learn's power_transform function, a powerful tool for data preprocessing. It's like a versatile toolbox for shaping data to fit machine learning models better. This sets the stage. It's a multiple-choice question testing understanding of the power_transform function and its capabilities. We'll be evaluating several statements to see if they are true or false. Statement A claims that power_transform always uses the Box-Cox transformation. Let's see if this holds true. We need to remember what Box-Cox is. Statement B suggests that power_transform can handle data with zeros or negative numbers. This hints at the flexibility of the function, perhaps using a different method. Statement C states the main goal of power_transform to stabilize variance and make data look more like a normal, Gaussian, distribution. It's all about improving data quality for modeling. Statement D mentions a crucial constraint. If you use the Box-Cox method, your data needs to be positive. This is a key constraint to keep in mind. This is a multiple-choice question, testing your knowledge of the scikit-learn's power_transform function. The question focuses on understanding the different transformations used by the function and when to apply them. Think of it as a fun quiz to see how well you understand data preprocessing. This statement is incorrect. The power_transform function in scikit-learn doesn't always use the Box-Cox transformation. It can also use the Johansson transformation, depending on your data and the settings you use. It's flexible that way. This statement is correct. The Johansson transformation is specifically designed to handle data with zero or negative values, unlike the Box-Cox transformation. So, if you have such data, power_transform will use Johansson automatically. This is absolutely correct. The main goal of power_transform is to improve the normality and make sure the data's variance is stable, which means it makes the data look more like a bell curve. This is important for many statistical models, as they perform better with normally distributed data. This statement is correct. If you explicitly choose the Box-Cox transformation, by setting the method parameter to Box-Cox, then your data absolutely must Contain only positive values. Otherwise, the transformation will fail. This is a crucial constraint of the box-Cox method. Scikit-learn's _power_transform is a function used for data preprocessing. It's a powerful tool that helps to transform data features exhibiting non-normal distributions, making them more suitable for certain statistical modeling techniques. Think of it like a data chef preparing your ingredients for a delicious statistical recipe. This section presents a multiple-choice question about the _power_transform function, testing your understanding of its capabilities and limitations. It's designed to make sure you really grasp the core concepts. Let's see how well you know the function. This sets the scene for the quiz question. The question focuses on how to use _power_transform correctly. It's crucial to understand the different transformations used by this function. This statement is incorrect. _power_transform is flexible. It can use either a box-Cox or a Yo-Johnson transformation, depending on the data and specified parameters. This is correct. The Yo-Johnson transformation, which is an option within _power_transform, is specifically designed to handle data that includes zeros and negative numbers. It's very versatile. Absolutely. The main goal of _power_transform is twofold. It aims to make the variance of the data more stable and to make the data distribution closer to a normal, Gaussian, distribution. This is important for many statistical analyses. This is a crucial point. The box-Cox transformation, another option within _power_transform, only works with strictly positive data. If you have zeros or negative values, you'll need to use Yo-Johnson. The box-Cox transformation is one of the power transformations available in Scikit-learn's _power_transform. It's a mathematical transformation designed to stabilize the variance of a dataset and make it more closely resemble a normal distribution. Important note: this transformation only works with strictly positive data. The Yo-Johnson transformation is another option in _power_transform. This transformation is more robust because it can handle both positive and negative data, including zero values. This expands the applicability compared to the box-Cox transformation. This refers to a function within the scikit-learn library in Python, used for data preprocessing. It's designed to transform features in a dataset to have a more normal distribution, which is often helpful for machine learning algorithms. This indicates that the following text presents a multiple-choice question, testing knowledge of the _power_transform function and its behavior. This sets the scene. The question revolves around using the _power_transform function in scikit-learn to preprocess data with features that aren't normally distributed. It's a real-world scenario, implying that understanding this function is practical. This is one of the multiple-choice options, implying that the _power_transform function might use the box-Cox transformation. The statement needs to be evaluated for truth. This option explores whether _power_transform can handle features containing zero or negative values, hinting at the possibility that it might employ a different transformation method, like the Yo-Johnson, to address this. This option probes the core purpose of the function, to stabilize the variance and make the data distribution more like a Gaussian, normal, distribution. This is a key property for many statistical models. This option examines whether there are any data restrictions imposed when choosing a specific transformation method within the function, particularly when box-Cox is used. It suggests the presence of parameters and their effects. This section header indicates that the overall topic relates to data preprocessing, meaning that data is being prepared and cleaned to improve its suitability for analysis or modeling. This refers to a function, power_transform, within the scikit-learn library in Python. Scikit-learn is a popular machine learning library, and power_transform is specifically a tool used for data preprocessing. It helps prepare data for machine learning models by transforming features to have a more normal-like distribution. This section introduces a multiple-choice question designed to test knowledge of the power_transform function's capabilities and limitations. The question will assess understanding of its parameters and how it works with different data types. This is the actual question, asking about true statements concerning the function. It sets the stage for evaluating different claims about how the power_transform function behaves. Each subsequent row lists a statement to be evaluated. This statement claims that the power_transform function exclusively utilizes the box-Cox transformation. The box-Cox transformation is a statistical technique to make data more normally distributed, but it requires strictly positive values. This statement suggests that the power_transform function can handle a broader range of data including zeros and negative numbers by using the Yo-Johnson transformation. The Yo-Johnson transformation is another statistical method similar to box-Cox but can handle zero and negative values. This statement explains the main goal of power_transform: to improve data normality by stabilizing variance, reducing spread in data, and making the data distribution closer to a Gaussian distribution, bell curve. This statement highlights the specific requirement when using the box-Cox transformation with the function. It emphasizes that if you choose box-Cox via the method parameter, the input data must contain only positive values. This indicates the final step, selecting the correct answers from among the statements provided. You need to determine which statements accurately reflect the behavior of the power_transform function.